Welcome. Today we're diving into simple harmonic motion or SHM using a classic example, a mass attached to a spring on a smooth, frictionless surface. Imagine gently pulling the mass to one side and letting go. What happens? The mass moves back and forth in a regular, repeating pattern. This type of motion is called simple harmonic because it's both simple and follows a harmonic or wave-like pattern. Throughout this video, we'll use bright visuals and clear labels to help you see exactly how SHM works, making it easy to understand even if you're new to the topic. Let's look closely at the motion. When the mass is at the center, it's at the equilibrium position. This is where the spring is neither stretched nor compressed. If you pull the mass to the right, that's called maximum displacement. At this point, the restoring force from the spring is at its greatest, pulling the mass back toward the center. As the mass moves, labeled arrows show displacement, velocity, and acceleration. Notice how the direction and size of these arrows change. At maximum displacement, velocity is 0 but acceleration is highest. At the center, velocity is greatest but acceleration is 0. These relationships are key to understanding SHM. Now let's connect what we see with how it's described mathematically. On one side, you'll see the mass moving back and forth. On the other, a graph of displacement versus time appears, tracing out a smooth sine wave. As the mass moves to its maximum displacement, the graph reaches its peak. When the mass passes through equilibrium, the graph crosses 0. This side-by-side view helps you link the physical motion to its mathematical representation. The repeating pattern of the sine wave matches the regular oscillation of the mass, making it clear how SHM is both a physical and mathematical phenomenon. Wrap up. Simple harmonic motion is a foundational concept in physics, showing up in everything from musical instruments to engineering designs. By understanding how a mass and spring move and how this motion connects to sine waves, you gain insight into many real-world systems. Remember, SHM is all about regular, repeating motion with forces and velocities that change in predictable ways. With these visuals and explanations, you're now ready to recognize and understand SHM wherever you see it.